Welcome. I am Esther Park Lee, and I am a PhD candidate in the Energy and Industry Group at the Faculty of Technology, Policy and Management of the Delft University of Technology. My research is about exploring the role of contracts in the integration of the car as power plant system in low-carbon electricity systems. In the previous lecture, we introduced the concept of the car as power plant, where fuel cell vehicles, while parked, which is over 90% of the time, are used to provide vehicle-to-grid services. In this module, we will address the role of contracts needed to implement vehicle-to-grid in the real world. In this lecture, we will have a closer look at some contract types and explain what their consequences are to the actors involved in the vehicle-to-grid service. With a high number of electric cars in the future, aggregators representing large numbers of individual fuel cell vehicles in a car as power plant system could operate in electricity system and provide system services to electricity system operators. If the aggregator trades power from the vehicle in several markets, vehicle-to-grid contracts are needed. To cope with different needs from the aggregator and car owner perspective, we developed three contract types for vehicle-to-grid. First, price-based. Secondly, volume-based. And thirdly, control-based contracts. These contract types can be used to attract heterogeneous prosumers with varying needs within systems with distinct characteristics and goals. And by prosumer, we understand a person who consumes and produces electricity. The term is a mix of the word producer and consumer. Although the aggregator can offer energy from cars in the markets, it also has to make decisions about the operation of individual vehicles, taking into account the different needs and preferences of the drivers and the technical characteristics of the vehicles. These aspects, which define the availability and the activation criteria of each car, delineate how it can be operated by the aggregator and have to be explicitly defined in a contract. Price-based vehicle-to-grid contracts involve a price signal for the activation of vehicle-to-grid. The driver defines a minimum price he wants to receive for vehicle-to-grid. Therefore, the aggregator will only use the vehicle when he can provide this remuneration, for example, when the market price is higher, and as long as there is enough energy in the vehicle. This type of contract could be used for drivers to participate in the wholesale energy market, where average prices may not be high enough, but peak prices can make vehicle-to-grid profitable. Volume-based contracts involve the commitment of a predefined volume of energy within a certain time interval. This means that the drivers can limit the amount of energy they're willing to provide. That's the maximum volume. Volume-based contracts can be attractive for drivers who have a very predictable driving schedule and can be plugged in regularly, for example, at the workplace parking facilities or at home. With control-based contracts, the driver cedes control to the aggregator as soon as the car is plugged in. The availability is defined by the time interval, which could be predefined, pre-committed, or informed by indicating the expected departure time. This may be the contract form with lowest complexity, and in the absence of a time interval commitment, it gives freedom to the driver to plug in anytime. However, once it's plugged in, the driver cannot limit how much energy may be used by the aggregator. Control-based contracts could be attractive in cases when vehicle availability is high without commitment. For example, with large fleet of fuel cell vehicles that are usually plugged in at very regular times, or when volume commitment beforehand is not necessary because it's not scheduled ahead by the aggregator. These three contract types show different ways for drivers and aggregators to make agreements on the availability and activation criteria of the flexible vehicle-to-grid resources. And the main differences are the level of commitment of the plug-in time and the activation criterion, either the energy available, volume, or a minimum price preference. In each case, the aspect over which the driver has control is different. In practice, hybrid forms of contracts could be used by aggregators to ensure a certain level of participation of drivers. In terms of implementation of vehicle-to-grid, These contract types we just discussed can be used by aggregators to choose a market for vehicle-to-grid and then attract drivers with the characteristics that can be suitable for that market, or vice versa. Also, aggregators can use the structure of contracts to design incentives for the participation of drivers. For example, they can reward availability, energy, or the commitment of time or volume.